Hey guys, so today I want to start by asking you a question. What if I told you that you could expand your Android app's existing market to millions of new devices without having to rewrite your app? Sounds like magic, doesn't it? Well, with the Amazon Appstore and Windows subsystem for Android, this is now a reality. My name is Anisha, and I'm going to tell you how you can take your Android app to the desktop. Just by submitting your app to the Amazon Appstore for Windows, you can have your Android app available to millions of users who already spend hours in front of their Windows devices every day, enabling so many new scenarios and use cases. Even from a user's point of view, how great would it be for me to have my favorite mobile app or game available on my desktop monitor without having to open my phone? Playing Angry Birds at work just got so much easier, didn't it? Sorry, Mr. Bezos. Well, as developers, I'm sure you're wondering how you can become part of this opportunity to reach millions of new customers. So let's jump right into it by first understanding the technology that makes this all possible, the Windows subsystem for Android. This is what enables your Windows 11 device to run Android applications. The Windows subsystem for Android runs using the virtual machine platform feature along with the Windows subsystem for Linux feature of Windows. However, for now, we should note that WSA, so Windows Subsystem for Android, is currently only in public preview and available to customers using Windows 11 set to the US region and Amazon customers with a US registered account. However, all you kind of really need to do is make sure that you're set to the US region on both your accounts, and you can test your apps on Windows 11. Second requirement is you have some PC-specific requirements. So you must also meet specific Windows 11 requirements, such as have 8 GB of RAM, SSD storage, and a full list of these requirements can be found on this link on screen. So you've got your laptop, you've got your US registered account. What do you need to do to set up your dev environment? Well, what if I told you it could be done in just 3 steps? So first step, install the Amazon Appstore, one button click. And while this is happening, the Microsoft Store will install in the background. The Microsoft Store will install the Windows subsystem for Android silently in the background. And once it's installed, you can log in with your existing Amazon account. If you don't have one, I'm shocked. You should probably get one. You should also remember that you need an Amazon account to create an Amazon developer account. So that's why you need the Amazon account. Once you've installed that, you need to configure the Windows subsystem for Android settings app. So that's the app you see on screen now to test and debug your app on the Windows 11 device. And to do that, you just need to set developer mode to on, which is that little button down there. Just toggle it on and off. That easy. And finally, you just need to connect to the Windows subsystem for Android virtual machine. And to do this, you have 2 options. So you could run an ADB connect command with the IP address that you can also get from the settings app, which you should be able to see there. Or you can run using the ADB command, using ADB connect with the IP address. Or you can use your normal work streams, so you can connect without having to leave Android Studio. So WSA is recognized in Android Studio as an Android device. So you can see here, I can either use ADB Connect to the VM, and then the device is available at the top. So you can run and debug your apps directly from Android Studios. And so once I've connected to ADB, you can see it running as an app on my Windows 11 PC as you would expect it. And you can use your normal developer tools that you usually have or probably used to from using Android Studios, such as enabling layout bounds to quickly test how easy it is to test on Android apps. So that's it. Once your app is available on Windows 11 devices on the Amazon Appstore, any user with Appstore installed on their device and an Amazon account can download and install it as usual. So you can see how easy it is. You literally can use Android Studio as you would, or you can use ADB and sideload your app. But what I really want to talk about is the best practices and optimizations for the desktop, because it's a different form factor, which you're probably not used to for Android apps. And we've had a lot of talks today about optimizing for different configurations, for the desktop, for the larger screen, and really great practices. Sorry, if you haven't seen their talks, definitely recommend checking them out. But these are the recommendations that we have specifically for Amazon Appstore. So if your app has dependencies on specific services, for specific app stores, I recommend that you identify which app store was installed to use your app, which was used to install your app. And this is because obviously different app stores will have different SDKs, and if you do this, it's a guaranteed check that you will know which app store was used to install your app. And you can use this with this get package installer name method, which allows you to ensure that your app is then surfacing the appropriate services regardless of the device type. So you could obviously always check if you're using a Fire tablet, but this is a guaranteed way to check that it is installed using the Amazon App Store. And once that method is run on apps installed on Windows 11 via the Amazon App Store, it will return the string com.amazon.venezia, which will tell you that was installed using the Amazon App Store. And then you can use Amazon services like Amazon in-app purchasing or Amazon device messaging or what other Amazon services you might need for your app. So the second one is probably one of the larger things that we need to consider, which is ensuring that we're accounting for windowing configurations. So Windows Subsystem for Android launches every Android app in a free-form windowing mode, just like other Windows apps. So if you've ever run an app from your Windows machine, you'll see that it pops up in a free-forming window like most apps do. This means that you have to consider how your app works on a range of different form factors. By default, your app will launch with an initial window size of 1280, so 1280 by 720 pixels, as this is the minimum screen requirement that Windows enforces. Now, this default behavior most likely works great for most apps, but if your app is best experienced at a different size, you can modify your initial size by specifying your preferred window size on launch using dynamic launch bounds programmatically. So your app can also participate in Windows 11 features like Snap Assist, the rich snapping experience that Windows 11 allows you to do, amongst other things. So, multi-monitor support, and there's loads of, cool things that Windows 11 can do. But what I really want to talk about is how can you, as a developer, ensure that you are allowing for the dynamic configuration changes and ensuring that your app is dynamically responding to different form factors. So I'm sure you've heard a lot about Compose today, so I'm still going to be talking about Compose because it has some really great methods and libraries that you can use to ensure that you are dynamically changing your UI. So this library I've specified here is the Material 3 Windows Size class, and this contains everything you need to understand programmatically the dimensions of the window your app is running in. And there's a lot of really cool information on this library, again, available. I won't go too much into detail, but I want to show you how I used it in a demo app and how easy it is to use it. So you can specifically use the Calculate Window Size class to retrieve the current window metrics. And you want to do this because, your device, or if it's your Windows machine, can be launched in, it's usually going to be launched in portrait mode, but you want to make sure that you're checking for what size it was launched in. So this method will return Windows Size class attributes that you need to check this. So in this specific case, we're returning the Windows Size class with size. And there's three different, predefined buckets that your app can fall into. It can be compact, medium, or expanded. So once you use the Windows Size class attributes, you can then say, okay, so if my class is compact, all right, my app is going to launch in this compact mode. Or if it's in medium, then okay, we have reasonable space, and we can launch other apps with it together. So you can do these things programmatically and dynamically and build your UI with the composables that you desire respective to the width of your app. So in the demo app, you'll see in a few seconds, we then pass that width size class as an argument to our app composable to be used. And then within the composable, we can check if the screen windows is expanded and build our UI whether we want to have our drawer on the left-hand side or whether we want it to not be displayed. And so that's what I'm saying here is if the screen, we set the variable is expanded screen if we're going to specify that. So this is the demo app. So as you can see, this is it in a normal mobile frame, and then I can resize it. So if I resize it, I will see that my app behaves differently because I'm using those classes to specify that now my app isn't in a small screen mode, it's in a large screen mode. So my window menu bar on the right, it will disappear if I'm on a large screen, or I can expand it if I'm on my mobile screen. So really easy to specify how you want to show different composables based on the width of your app. So as Android developers, you probably know that configuration changes will lead to the activity being destroyed and recreated. However, there are many ways you can save the state during these configuration changes when your app resizes. So you can use onSave instant state for activity fragment or views. You can use save state handle for a view model object, or you can use remember savable for your composable items to persist the state and save and store the UI to the state that it was of your activity before you had those configuration changes. Now, if you're brave, you can use the onConfiguration change method to handle the window resizing dynamically yourself, and add a config change declaration in your manifest, like what you see on screen. And I would really recommend not to do this, which is just ensure that your app is not resizable. So 3 ways you can do it. Last one we say no, second one brave if you're brave, and first one is what is probably usually recommended. So if you decide to go through that last method, which is resizable activity false, and you're saying, okay, my user can't rechange anything. If they try and rechange their app size, like we don't want to handle it, this is what's going to happen. You're going to have a mismatch of your Windows size and the app's context size, which will lead to like letterboxing or pillar boxing. And as a user who has a large screen, do you really want to be shown a phone screen and told, okay, this is the only window you're going to interact with? Probably not. So you want to make sure your user isn't placed into the app compatibility mode. Next, we have to think about input methods. So when we're interacting on a desktop screen, there are other things to consider other than touch, such as the keyboard, the mouse. And alongside the keyboard and the mouse and keyboard, we have to consider touch as well, obviously, but we also have to consider things like if a user might use a stylus. So many existing Android apps already support keyboard inputs and keystrokes for their use cases. As an example, some games might already support movement facilitated via the keyboard, so WASD keys might be up, down, left, right, alongside touch. However, in terms of mouse input, similar to the keyboard input, there are many scenarios that are automatically covered in Android. So scroll wheel actions, dragging and selecting, and highlighting are often supported. So WSA supports mouse down, up, left, right movements as touch events by default, and for compatibility with most apps, and is compatible with most apps that expect touch as an input. If a text is focused, then the input is reported as a mouse input to ensure that text highlighting and cursor placement follows the mouse paradigms that you'd expect. However, as developers, there are probably some optimizations that you would want to implement yourself, such as right clicks, hoverable states, etc. And WSA will give you this, it works with the same as Android apps, and you can support these as well. So yeah, account for keyboard and mouse specific events, and WSA reports these as default. But what if you want to ensure that your input devices are handling things the way they're expected? So for keystrokes that aren't anticipated by Android frameworks, like apps need to handle these behaviors themselves. So for example, pressing enter for submitting text input in an edit field text, or arrow and tab navigation to toggle between 2 different input forms, you need to handle those events yourself. So if a text is focused, WSA will inject characters translated via the Windows subsystem for Android into your input text method. However, if your app uses custom text controls, you need to ensure that those text controls are following Android best practices. So let's look at an example, right? How can we intercept when a key is pressed using a Jetpack Compose library? So first thing you have to do is declare a modifier. So once you've declared this modifier, the modifier will be on preview key event modifier with the selected keys being filtered. So with the event being, say, key up, this will correctly handle the click of a button when it has been released. And in this case, we also assign a method, we assign the method as an argument to define the behavior that we want our app to execute when that desired key, so our key up, is pressed. And because the modifiers can be concatenated, you can assign the behavior to any key you want. So you can chain the reactions together. So to intercept the click of the mouse and differentiate between left or right clicking, you can create your own modifier using the pointer input. And in this case, we intercept a pointer event and check the button type. So right click is secondary pressed, and we want to then execute that right block of code in case the right button is clicked. And the else statement is saying otherwise we'll intercept this block of code if it's the left click. So again, Compose has many libraries that you can use to really easily intercept all the different key inputs, mouse button inputs that your app may receive that they wouldn't probably receive on a mobile app. And finally, what about hover? So to intercept a hover event of the mouse, we have to use the hoverable modifier. And this will need an interaction source that will be able to listen to the hover event and change the state variable. So in this code, we use the hovered event to change the color of the border stroke in the image composable item. So we were saying if we're hovering on our composable item, we want to make sure that the color changes from red to blue and vice versa. So this block of code, really easy. When you hover over your, in this case, our little article, you can see the border changes from red to blue. So kind of last but not least, your apps can send a variety of obviously different notifications to your machine. So these notifications would work as they would on any Windows machine. So WSA handles those notifications as you'd expect and mirrors what normal Windows notifications that you would have. So we could have, our normal notification, image notification, calendar notification, and everything will be handled as you'd expect. You can even interact with the notifications, and as you can see, they will be sent to the app as you'd expect it to be. So lots of different kind of notifications that you can interact with. So that feature isn't lost if you're moving from mobile to desktop, which is really great. So if you're worried about that, don't be. It is accounted for. Sorry, clicking through all the different notifications. So as developers with apps, I'm sure on multiple app stores already, there are some differences that you have to consider when it comes to supporting your app on Windows. So Amazon provides a useful suite of equivalent APIs and features to modify your Android app to get it working on Windows 11 specifically. For example, for billing, you can use the Amazon in-app purchasing SDK. For cloud messaging, we have our A3L SDK, which not only supports Amazon device messaging, but also supports Firebase cloud messaging. So you can have one SDK do both. And we have, for our specific in-app messaging, you can use ADM. So there are a lot of abstraction, like A3L is an abstraction library. There are our own libraries you can use to really easily port your app from whatever app store you're using the same kind of services you may be used to. In fact, if you go on our developer portal, we have really easy workflows that show you what you would need to port your app from whatever app store you are porting it from, to make that journey really easy for you. If you're using, Firebase SDKs that depend on Google Play services, we have those SDKs that may be supported in their Amazon form for Windows machines. So as of now, there are thousands of apps that have been included in the preview, so the preview for Windows 11, with additional apps being continuously added as we improve the features for WSA and as more features become available. As testing capabilities continue to expand, we are constantly testing new apps that we want to include. So if you're not already developing for the Amazon App Store, the best way to get started is literally just submit your app. It's free to do. Why not do it? And with the general availability, details will be coming soon. As soon as they are released, you can stay up to speed with just by scanning that QR code. It'll take you to our dev portal, socials, whatever you need. Otherwise, you can join, myself and Gio, my colleagues in the audience over there. Like, we have a live stream, and our next live stream will be covering, again, other cool features of Windows subsystem for Android. So again, that's on the QR code. You can scan it. So in the meantime, just submit your app, or you can test your app and ensure that it is optimized for the desktop experience, because the desktop is coming. Thank you.